Hi, welcome to The Context.
Today we're going to talk about agents, what an AI agent is, and we look at how new technology are changing the way we build and use agents.
So I want to have a conversation about agents. So we've been talking about large language models for a long time. We've been talking about generative systems in general for a long time. People are quite used to the idea of chatbots, and that makes sense. And now we're starting to talk more and more about agents and agentic systems. And I think that some people have got a reasonably good idea about what they do and what they can get out of them. But I thought it'd be interesting to dive into a little bit more of a detail about what they actually are. So as we start to build them and we evaluate the frameworks we might want to use and the architectures we might want to use, we've got a sense of actually what's happening under the hood. How are these systems actually working? So I have a question for both of you, and I have an answer for myself as well. So I'd like to sort of spread this around. But I want to ask you, what is an agent to you? Because this is something I've noticed, is that there are some conflicting ideas with definitions. So let's see if we agree to start with. I guess maybe I'll start with Danilo, because you're over on the side for me at the moment. What is an agent for you?
So an AI agent for me is a sort of program that uses an LLM to solve a problem. And the key difference for me to an agent and a traditional use on LLM is that the path to solve the problem and the way the LLM will work, which kind of information the LLM will have access to, all the path from the problem to the solution is going to be determined by the LLM itself, and it's not predetermined before the agent has run.
Gotcha. Tiffany?
It's weird to think about it, just because it feels like the definition of agents has kind of changed in a very short period of time. The first times we talked about it, it was LLMs being able to do things, like to have access to APIs and like do actions. So I remember there was a time where we talked about agents. It was basically an LLM being able to make a decision, like to act upon something. Or actually, basically at the very beginning, we talked about the difference between just an LLM being able to discuss with you versus an agent being able to discuss with you and also do something in the result of the conversation. And
so I guess the difference between chatbots and actually, like you said, being able to do something. Because a chatbot, you can give it a prompt, so in the most basic sense. And actually, I think if you think about the Claude web user experience that you can do, you can log in, you can have a go with Claude AI. And my understanding is that is just a chatbot, and so you can go. It's a very powerful one, but it's a chatbot, so you can go in and you can prompt it, and it can do a thing, and it can respond back to you. But it's very much generating an output based off your input. It's almost as basic as you can get and as raw as you can get in terms of interaction with generative systems, and super powerful. Then you bring an agentic flow to it, and I guess the agent word comes from having agency. Like you have agency, so you can do and you can achieve stuff. So you can connect in with tools to the outside world. That on its own could become, I guess, a complex workflow that could actually have a start and an end. But to the point that we've been saying here is that it's actually an iterative loop, so it can call a tool and it can figure out and look at the response from that tool and actually prompt it again. And I guess we've probably all had to go at creating our own agents and coding our own agents. Is we actually have set up loops where the output from the tool comes back in and prompts the agent again, and essentially prompts the LLM again to then process again. And it has to have its own self-determinism about whether it's actually reached the conclusion of what it's trying to do by doing that iterative loop and maybe other tool calls and having the self-determinism of what it's doing. I feel like I think we probably all said the same thing, and that feels like an agentic workflow to me.
Yeah, and connecting to what you said, I've seen different implementation of agents that try to avoid this loop, because this loop has two drawbacks. That now normally tools are called one at a time. So if to make maybe one of these loop, you need to call three tools. You have to call them, and you have to go through an agent each time, even if you could technically have a tool invocation with three tools, but that's rarely used. But still, no, if one tool needs the output of the previous tool, you need to go through different steps. So I've seen this new way of working where I would like to experiment more, where each iteration of the agent is just the agent writing a program that calls all the tools, maybe in parallel if it can, works automatically with the result of these tools using procedural programming, and then gets the final result of this program. And then this final result is evaluated by the agent only once, and then the agent can determine, okay, this is the final result, I give it back, or no, I need to work more, and it writes a new program that is the new that replaces the new loop for the agent itself.
That's cool. So it's you ask a question, or you make some request of the agent, and then if I'm hearing this correctly, so it's going to go and write a tool essentially to solve that, run that, and see whether that actually provided the output. And then it might well do, if it's powerful enough to do that one shot, but if it can't, it can loop around again. Is that basically it?
So sort of. So let's make now the classical example where maybe I ask, this is my email, I want to know my customer status on the company CRM system. And maybe the agent has one tool that translates the email to an internal customer ID, and then another tool from the customer ID will get all the information on the customer that needs to be provided back. So normally this works in steps. So the agent looks at that and says, I need to build a plan. I need first to call this tool with the customer email to get the customer ID. It gets the answer. Then the agent again has another invocation of the LLM that says, I have this information. I have all the information. I can call this other tool and get the result with the customer status. And then the LLM looks at its third invocation, we look at the result and say, okay, now I have everything to provide the answer back. So I end the loop. This different approach is, I have the email, I need to call these two API endpoints, so I write a Python or a JavaScript program that will call the first API, get the result because I know the syntax of the result of the API, and then call this other API, so inside this JavaScript code, get the customer information, and then give me the output to me. So I write the program, the LLM writes the program once, runs the program that calls all the different tools, and maybe some of these tools can also be called in parallel sometimes, so it's also faster. Then it gets the final result, and this, as you said, could be the final result, or maybe the agent will do another step that is write another program that calls n tools in parallel or in sequentially to go further.
So this sounds a lot like the experiments that I did with Hugging Face's small agents. So I think that was their plan there, that they're following this technique. And yeah, basically it's just getting a Python execution environment and trying to solve the problem just by writing Python code. And I guess this speaks to me, like, as someone who uses the developer tools and like generative developer tools like Amazon Q Developer, and like I am asking it to solve programming problems for me. It's similar. It's not the same, but it's kind of similar. I'm feeling I can see the power of generative AI as it's starting to write code and solve those problems for me. I'll be honest with you. I've used this technique in report writing that I've done. I really want to go and grab a data set and actually pull it together and then do some analysis on that data and spit out some numbers so that I can make my point. And rather than sort of starting out by doing some web research and sort of trying to find some reports and then putting them into Excel and whatever it is I have to do, I just go to my IDE and say, hey, this is what I need. Go do this. And I have it write code. It goes off. It goes and grabs data, and I go and grab myself a cup of tea, and when I come back, it's got the data. So I know that's possible. So I guess doing that inside of an agentic flow could make that much quicker, more. I suppose as well, it takes far less tokens. That's kind of the point, right?
I think there's a good balance because you write the program once, then you call end tools. Now, I always find it silly when you call a tool and then the model gets like one word back and then has to call another tool. So it's probably not the most efficient way of invoking LLM. So in this way, the LLM should be able to really minimize the number of invocation and only and run all the procedural stuff, the tool invocation in sequence or in parallel, and process the result as much as possible without having to go through a generative AI model.
Yeah, that's interesting. That's an interesting idea. I guess I've certainly built agents in the past that have got code execution environments. So I suppose in a way that's an easy way to start experimenting with that architecture straight away.
Yeah, I think the biggest problem here is to find a name for this kind of architecture because all the names with code and agents have already been taken. So if you call this coding agents, now it means something else. So I'd struggle to find a way to give this kind of architecture a name that doesn't create confusion.
So what about this paper, which Dennis, who can't be with us on this show today, but he shared it with us, right? It was the program-aided language models. Is that what we're talking about? It
could be, because I remember reading about it. Maybe that was where I read it about it.
Yeah, and I remember that this was the paper, I believe, that inspired small agents as well. We can put a link to that in the description below here as well. And I did actually do a video. It's a very, very basic video on small agents. So we could put a link to that as well under this video too.
So I've been using MCP servers more in my day-to-day job with models and also with desktop application like Cloud Desktop, for example. Are you seeing that all these MCP servers are like there's a proliferation of MCP server and this can create even confusion with models that now have maybe 50 or 100 tools that they can have access to?
Maybe we can start with a little introduction about what MCP is, just to make sure everybody's on the same page. Yeah.
Absolutely. And also, by the way, drink, because we're talking about MCP. I was a little bit concerned that this video was going to go without us talking about MCP. We almost must have this in every video. So model context protocol. And I guess why it's relevant to this conversation is because it's a protocol which sits in between LLM powered applications on one side. We talked about this in the last video, right? But LLM powered applications on one side and the tools that they use or the resources they use on the other side. And one of the primary cases we give for LLM powered applications are agents. And that's probably the one of the largest use cases. Agents of different kinds. And so it's a way of decoupling these things. And it's a protocol which actually encapsulates natural language in the descriptions of the resources and tools which are being used. So when the agent wants to, or when the agent is pointed at an MCP server, it can, at runtime, discover what capabilities are on that server. So what tools essentially are there ready for it to use. So that's basically what MCP is. And it's a way for agents to connect with tools.
Are they agents then? Aren't they just LLMs? Because for me, the agent is the LLM with the tool. And so with MCP, as we decouple it, it's just like the LLM without the tools, but being able to, query the tools or find the tools. So is it an agent yet, or does it becomes an agent with MCP because it has access to the tools? I don't know.
I love that question. That's a great question. Yes. So an agent that's sitting there, which hasn't been connected to anything. Is it actually an agent at that point? I guess it has the capability of being, and it is more than an LLM, right? I guess because it's an LLM. Well, it's some code, which I think was Danilo's point right back at the beginning of this conversation. It's an application, right? It's an application that we can see the code of and we can create, and it's an application that is pointed at or connected with an LLM because. In almost all cases, it's going to be connected via an API to an LLM. It's a cloud-based one, unless you're using Ollama or something like that. It has the capacity for this sort of self-reflection and calling of tools. And I guess until you press run and it actually connects with the servers, then I don't know, maybe technically it's not an agent. I don't know. Danilo, dig me out of this hole. What do you reckon?
maybe the knowledge of the tools make it an agent. No, because you can decide to not use them, but the knowledge of the tools make them an agent.
I guess
knowledge is power, and in this case, knowledge is making you an agent.
Yeah, it's a semantic point, I guess, about whether before you've actually pressed run, whether it technically is an agent or not. But I guess going back to your point, Danilo, is that MCP's become really popular. And so all of a sudden, there's this massive proliferation of all of these different MCP servers which are available through all kinds of different transports. And that's maybe a conversation for another day. But you all of a sudden have all of these different providers of capability that are saying, here, connect into my MCP server. And so the temptation is to say, excellent, I'm going to do that. And I'm going to start configuring, 10, 20, 30 different endpoints to different MCP servers that all of a sudden each of those have, 1, 2, 5, 10 different tools and resources that can be used. And all of a sudden, agent sort of just crashes in a heap, because even with a large context, actually being able to, for the agent to be intelligent enough, for the LLM to be intelligent enough to actually keep track of all of those things is a big ask. And so, yeah, I definitely see this as a challenge. What do we do about it?
Well, one way to handle that is that maybe we will see more commonly multi-agent architectures where each agent has access only to a subset or to a coherent subset of these tools. And so, for example, I often try to give access to my agents to file system, to Git capabilities, maybe browser access, but these are three different things, no? You don't, even if you're building a team of people to solve a problem, maybe one is the researcher using the browser, one is the one who is committing the code using Git, and so on. So having multi-agent architectures that will partition this access to a coherent subset of these tools, I think it's a good way to reduce complexity. It's a common pattern in software architecture since it was born 100 years ago. So I think that's probably the approach, and maybe I could make a bet. So maybe in a few weeks or months we will see multi-agents in the traditional desktop applications that we all use with LLMs, because they will need that to handle all these MCP servers.
So much in the same ways that we have teams of people solving problems in a workplace, in a startup or whatever. Each individual in that team isn't completely across what each other individual is doing. There's no point in that. That's the point of teamwork, right? So the idea here is that we would have multiple agents working together, and each of those agents has its own set of capabilities. And whilst we might know at a broad level the kinds of things that agent can do, we don't need to know the details about each individual thing that they're doing. Or each individual resource or tool that they have access to. So I guess this is we talked about MCP doing the decoupling, but this is multi-agents doing even further decoupling from the ultimate input point, I guess, that we would have as users. So it's an interesting point you made about the desktop applications becoming multi-agent. I think this fascinates me from a couple of different angles. One is that I think it'd be really interesting to see how well that works, and to actually understand where the multiple agents are. Because, I mean, right now, for example, you could create a tool which is used by one of these desktop applications, and that tool itself could be an agent. And I'll just point out now that I do firmly believe that there will be a convergence between tools and agents. And maybe this is something we've sort of talked about in other episodes, but maybe this is something that we could talk about in the future as well. But the other thing is that, you're calling out here that the desktop tools are one of the prime places at the moment where we're using these, especially MCP servers. I would like to, I think you're right. I'm not going to take you up on that bet, because I think I think I'm going to lose. But what I'm also super interested in, and what I really, really want to see moving forward, is that we're not just talking about desktop applications being our agentic endpoints. Yes, that's super useful, but I think we'll start to see more of the sort of what I guess we traditionally call a line of business applications. And, the product and service that I have, which is cloud hosted probably somewhere, of course, that being the place where I have multi-agents in that is performing some sort of really useful function, so that I'm not expected to have a chatbot or a tool on my desktop to make everything happen. These things will happen anyway because I have agents running in my organization doing work for us. It's not something that I constantly want to have to tell them to go do that work. I want them to be automatically doing work and adding value and working in the background a bit more. Can we have that?
Maybe we can connect agents to maybe the internal chat systems or the email systems. And in the same way we would send a message or an email to someone to do something, we can do that and send it to an agent, and the agent will work for us in the background and then provide asynchronously an answer after some time.
That sounds like something I'm up for.
That's an interesting discussion when we have to look at the future and how agents can do work and collaborate with people and other agents. So if you're interested in that, look at the resources that we put in the description below.
Thank you all for being here, and see you next week.
Goodbye.
Bye. If you're interested in that, look at the resources that we put in this. I don't know. I really don't know how to say that. It's beyond me. I don't use YouTube, so in the description below. Okay, sorry.
In the description below.